Okay, lights, camera, action. Welcome everybody, welcome to the April meeting of the Ottawa Centre RASC. Welcome members and visitors alike. I think you're going to like what we have lined up for you. Just a quick show of hands, if I can even see them with the glaring lights there. So how many people have managed to see the comet in the last 3 weeks? Quite a few hands up. Excellent, excellent. Well, for those of you that haven't, and even for those of you that have, we have a really nice collection of imagery taken by a number of our members tonight there. So if you haven't had a chance to get out and see it, this is the next best thing. I think you'll enjoy it. Got a fairly packed agenda there, and so I won't waste too much time. Gary Boyle's going to talk to us about Ottawa skies. As usual, Al Scott's going to give us his astronomy news update. And then we've got a rather interesting talk about an ultralight Dob, which happens to have beamed in person here. So
Door prize.
is it door prize? Oh, get your tickets. I want one of those. Thanks, Michael. I didn't know that. That's a surprise to me. That's great. Mark is also going to talk to us a little bit about a special event that's coming up. We'll have our break, do our observations, show you some of these images that I'm talking about. Rob Dick will talk a little bit about things new and baking and shaking in the RASC governance. And then Bob is going to cap us off with a little bit of talk about astrophotographer's favorite topic, on-axis guiding. Yeah, I can't wait for that one. So good stuff. So without further ado, oh yes, we have members in the news. Yes, thank you for cueing me on that. We do have some members in the news. Roll them up. There we go. We have annual awards. And I have to, you have to excuse me because I didn't have much chance to go over this last night. But annual awards, we've got Rob Dick and Losing the Dark, by the way. Oh, where's my pointer? There we go. That was the video that we were just rolling there before we started there. So and Rob Dick, I believe that was the award for the work on the light pollution.
Deep Sky Defender.
Yeah, Deep Sky Defender of the Faith. Atta go, Rob. So excellent, yeah. We need to preserve our dark skies. Also, in the April on the April calendar page, we have sketches from our own Gord Webster. So some of his very nice lunar sketches, and nice work on that, Gordon. Another one in the news there, Deborah Saravolo took a nice shot of the comet back about, I think on the 16th. Yes, I think it was on the, I believe it was on the 16th. It was one of the wonderful nights that we did have, and that was published in the city page of the Ottawa Citizen. So nice piece of work there, Deborah. And that's it for members in the news. So Gary Boyle. Where are you, Gary? I know you're here. I saw you. There he is.
Marco!
You're working.
Marco!
Polo!
Marco!
Wearing black. No wonder I didn't see you. There you go, sir.
That's it. Thank you, sir. And welcome, everyone, to another month of Ottawa skies. They're up and they're pretty clear for a while. So I'm glad to see a lot of people have seen the comet. Once in a lifetime opportunity for this guy. It'd be 11,000 years for the next time it returns. And as we can see that, well, we've had some clear nights, but it's been so low. It's always been low on the horizon for people who have noticed it. So tonight it's just about over here, just a little north of the Andromeda Galaxy, and I'm sure we'll see some pictures of that later on. So we still have another week or so, or a couple of weeks, but it's fading. As I mentioned last month, about 1 magnitude fainter every 5 nights, and it's really whisking away, so it's now or never. Next slide. So here we are. Yesterday morning I was able to step out on my balcony. Since I live in South Mountain now, I get a lot darker skies, and just took this on my, in fact, Glenn Ledru's automated camera tracker, the Canon 450D, 135 millimeter lens, and 6 1-minute exposures stacked together. So I was kind of fighting semi-twilight. Although it was clear, it was low on the horizon, not a very dark sky, but still I didn't want to overexpose it too much, and also wanted to get the nice fan shape of the comet itself.
What's that other object there?
And this is actually the Andromeda Galaxy. So we're looking at almost a 3-dimensional array. The comet is about 10.5 light minutes away. and Andromeda is 2.9 million light years away. So a bit of a difference in distance.
And stars in between.
And the stars are between here and there. Next slide. Oh yeah, just bring it back a second, please. And also able to get M110 and M32. So just 6 1-minute exposures got these two galaxies. Great.
You got that in the morning now.
Yes. Yeah, 4:40 in the morning. I was up early yesterday morning. Yeah, because I had a nice, because in the western sky I have too many trees, but in the northeast, just beautiful horizon, right down to the bottom. Okay, next slide. This month is a great photo op with the planet Jupiter, which is will set around midnight, and hence by 10 p.m. next month, or by the end of the month. So we'll have the 10% crescent moon, along with Aldebaran, the Pleiades, and the Hyades on lucky April 13th at about 8:30 p.m. So it's a great digital op for that. Next slide, please. The Lyrid meteor shower is coming up on April 22nd at 2 a.m. It's going to be a late one because Vega only rises very late. So it'll start around 10 p.m. or so, all-night affair. Not sure what the lunar phase is on that, but let's hope we get some semi-clear skies. Next slide. And Saturn will be at opposition, meaning that Saturn will rise as the sun sets, and hence the planet will be out all night long for your viewing. And once you do look through a telescope, you'll be awarded with, next slide, with Saturn and many of its bright moons. You can see about 7 moons in medium-sized to large-sized telescopes. So it's a great photo op for Saturn. The rings are nicely tilted, whereas a few years ago it was almost edge on. So there's no excuse not to have some slides for Saturn next month, right? Right? Right. I have spoken. Great.
You take that one, Gary? That's really nice.
Yeah. I was lucky that they even had the names of the satellites.
Oh, excellent.
That doesn't happen too often. It's pretty rare.
Timing is everything.
Pretty rare. At the same time when I photographed the comet.
Excellent.
Next slide, please. And just where your favorite planets are in, finally Mars is lost in the solar glare. Venus is moving into the nighttime sky slowly. So by the end of the month and beginning next month, you'll see Venus low in the western sky. Great photo ops. So it's your last chance to look at Jupiter. It'll be setting in, like I said, midnight and by 10 p.m. by the end of the month. And the next is your usual lunar data. The pink moon, I don't name them, I just call them out. Pink moon on the 25th. Great. So just some upcoming events too is on Saturday the 20th is International Astronomy Day. As always, Museum of Science and Technology here allows us to set up displays and is a co-sponsor of it. So we should have telescopes set up at night, star party at night if it's clear, let's hope. So come one, come all on the 20th. Great place to learn astronomy. I think there'll be some lectures here in the auditorium also by Paul.
Hopefully.
Hopefully.
See. Yeah.
Great.
I have a bit of a conflict, but yes, it will.
For sure. No, it's a fun day because they'll also be even looking at the sun with very safe solar filters. These are telescopes designed to look at the sun. So it's not welder's glass or film that's exposed. It's the true expensive filters. If you've never seen the sun through a telescope, it's well worth your trip to come down and see it. And next slide, please. And then on May 31st at 8 p.m. here at the same museum here in the auditorium, David Levy will be doing a speaking tour. He'll be speaking amongst most of the centres in Ontario and in Quebec. And he actually starts off the tour here in Ottawa on the 31st, starting at 8 p.m. Tickets are free, but you are required to call the museum to reserve tickets. We don't want 1,000 people where we can only seat 250 for fire regulations. So absolutely free. Come on down, great speaker. And his talk is A Nightman's Journey, A Night Watchman's Journey, and just his whole repertoire of observing comets and sky watching as such. So it should be a great lecture. Great, thanks.
Tiny warning, Gary.
Yep.
There's nothing on the website from the museum yet about
No.
getting tickets.
The museum will be putting up information. They're slowly getting it together. I have given them this information. So the museum will be putting up as soon as possible. So keep checking the museum's website. Or you can always call them too. Great. Okay, great. Brian McCullough, can you please come to the stage? Paging Brian McCullough. Paging Brian McCullough. Are you there? We just have some lights, please.
What are you doing up there? I don't know.
There you go. I'm looking for you over there. Yeah, how you doing? Oh, look at this. Did you get the memo too? Dressed in black?
Yeah.
Sweet.
Yeah. Men in black.
Well, Brian McCullough has joined the Ottawa Centre since 1990 and is a life member. He has spent much of the time supporting City Council from one form to another. In 1997-98, he served as dual role as Vice President as well as editor of Astronauts. In 1999 and 2000, became President of the Ottawa Centre and helped to launch the Millennium Initiative, which evolved into the Smart School project. That'd be great. You start it, I end it.
Yeah.
That'd be great.
That's not end.
Well, no, but it's finally gelling. Brian has also presented many segments of the 10-Minute Moon, his favorite topic of astronomy. He's even taken on the role as meeting chair. While Brian's never-ending passion for teaching astronomy to children of all ages, as well as adults, has been enjoyed by school groups, workshops, guides, and scout nights, and here at the Museum of Science and Tech, where he is an educator. If you're wondering how many hearts Brian has touched, the capacity of Scotiabank Place would pretty well come to mind in the past 20 years. You're wondering why I asked for that number, last year?
Did you?
Yes, I did. I'm sure that Brian has even made a buck or two playing the penny whistle on the side. Brian's also been a frequent guest on CBC Radio and on an array of astronomy issues, and has authored many newspaper articles, particularly the Ottawa Citizen and other literatures. Happily married and proud father of 3 wonderful children, Brian was able, with the help of his wife Bridget, to juggle the never-ending hours between family life and the calling to teach the wonders of the universe to others. Because of Brian's endless efforts with the Society, I am proud to announce that Brian has won the Service Award of the Royal Astronomical Society of Canada. Congratulations, Brian.
Thank you very much. Thank you, Gary. Thank you so much.
Thank you. But it's bittersweet. Take it in, kid. Take it in. You've heard it.
Yes. Thank you very much. Thank you.
Now, there's a bit of good news and bad news. The good news is you've won the award. The bad news, you got to go to Thunder Bay to get it.
Yeah. Well, Chuck, are you flying to Thunder Bay? What's the story here?
Yeah, you can sit in the back seat.
Yes, in the back seat. Because the awards of the RSC are always presented during the annual banquet of the General Assembly. And if not, the National Office says it'll strap it on the back of 1,000 fleas and send it here eventually. So if you do not attend the GA, you will definitely get it.
Hard choice there.
Yeah.
Handshake.
Okay.
Hang on a sec, I gotta stack these, eh?
Actually, the original position.
Sorry, it's not a 60D.
Do you want a couple of tips on how to run one of those? I just bought one at the last RASCAPRIL.
Yeah.
One more. Oh, your flash is, I think your
That's
flash
okay,
is
it matters.
And you
Okay,
keep
We'll get one later.
Okay,
I
thanks
did
a lot.
get a
Thank you.
good one.
Congratulations. There you go, Brian.
Have a go, Brian.
And that should be it for me, folks. So Brian's award will look like this. It's not been given yet, but through the artistry of Chris Tarrant, thanks a lot, Chris, this is what it should look like. This was taken from Rob Dix that he won. What year did you win yours, Rob? 2011. Great. So we're running in the family here. Super. Okay, thanks a lot, folks.
That's Gary.
That's super. Well deserved. Well deserved, Brian. All right, next up is Al Scott with his astronomy news update.
Okay, greetings. So a couple stories for you this month. The first one may come as a shock. There's actually been a paper published from the International Space Station on science. So our $100 billion space experiment with a $2 billion experiment here that's called AMS. This is the alpha magnetic spectrometer, which is an international magnet that they've stuck on the side of the ISS. It's well shielded, though, so it doesn't actually orient the ISS like a tuning fork every time it goes around the Earth. It's a very heavy thing. It's actually a cosmic ray detector. And the reason it works better on the ISS than down here on Earth is because of the atmosphere. So this is one of the particular experiments that benefits by being up in space, because the atmosphere and the Earth's magnetic field don't protect it as much, don't protect the astronauts as much as well from the cosmic rays coming in at us from space. So the AMS has very precisely measured a small excess of high-energy cosmic ray positrons, which are antimatter. And it's measured them, it can actually measure the direction these are coming from, and they're coming from all over the sky. There's no particular single source to this. And what the investigators believe is that because of this, this could indicate the presence of dark matter, which, if it consists of weakly interacting massive particles, which are theorized to exist by some extensions of the standard model of physics, each of these weakly interacting massive particles are their own antiparticle, and when they bump into each other, they will annihilate and create high-energy positrons and electrons. And this is what they believe they may be detecting, although they're not sure. And this isn't actually the first time this has been detected. This is a verification of other satellite detections. But if you have a $2 billion experiment on a $100 billion spacecraft, you better publish something. So the AMS collects its data by recording the number of particles that pass through its collectors. It can measure the kind and the energy of the particles and the direction they're coming from, mass, velocity. So each one of these pieces of data is a particle event. Since its activation on May 19th, 2011, AMS has collected detailed information on more than 31 billion individual particle events and downlinked this data for study. This is more data on charged cosmic rays than has previously been collected in the history of human physics studies. AMS continues to collect data and will continue to refine the results, collecting about 1.4 billion particles every month. The dark matter signal that they expect to see, that it's been theorized to see, would show that the ratio of positrons, antimatter, to electrons should rise at higher energies, near the energy of these supposed WIMPs, weakly interacting massive particles. And then at higher energies, they should drop off precipitously because there's a certain mass associated with these things. AMS sees a rise in its data, but the drop-off, if it exists, seems to happen at higher energies than the experiment has so far searched, above 350 giga-electron volts, or 350 times the mass of the proton, for comparison. After 250 GeV, the experiment sees the spectrum appearing to plateau, but they need to collect more data to refine whether or not there's a drop-off. So stay tuned. There may be an interesting, I'm sure there's going to be more papers coming out, and there may be something actually to announce a discovery. So interesting news, potentially. My second item is on observational cosmology, a field that's been enabled over the past 20 years or so with a series of satellites measuring the microwave cosmic background. This actually, what you see here is an all-sky image composed by the Planck mission, which is a follow-on to WMAP, which is measuring the oscillations in the microwave background to extreme precision. If you look at the microwave background radiation, it's about 2.76 Kelvin in all directions. But on top of that, there is a dipole. In other words, it's a little bit warmer in one direction than the other, and that's because we're moving in one direction with respect to it. Our galaxy is moving towards a cluster of galaxies, and they have to take that off. Then they have to take off all the background from all the stars in our galaxy and all the dust in our galaxy, and what they're left with are these little oscillations, about 1 part in 10 to the 5th of the overall signal. And so they've been getting more and more precise and higher resolution at measuring these little oscillations. What these oscillations are effectively sound waves that were echoing through the plasma of the universe about 380,000 years after the Big Bang. And by looking at these sound waves, what you can tell is you can understand a little bit about the density and viscosity of the universe at that point in time. And what that tells you is it gives you information on the ratio of matter to dark matter and to photons and all these things that make up the universe. So you can have an idea. We know what temperature roughly the universe was, and we can see that it was about, at the time it decoupled, what happened was electrons and protons recombined, and the universe suddenly became transparent to radiation. It turned from a plasma to a neutral gas. And at that point, the light was no longer scattering. It was actually able to go straight after that point. And now we're seeing that light from the farthest reaches of the universe. And what we're seeing is this it's basically a plasma, what we're seeing, but it's several billion light years away, and it's been redshifted down from a temperature of 3,000 Kelvin to about 3 Kelvin. And so it's really interesting what this actually represents. And because they now have extreme precision, they can refine the theories of what the universe, of how the universe evolved and what it was made of. And you can see down here in the bottom, we have a little graphic of before Planck and after Planck. And what this does, you can't read it, but it's basically, it shows you the ratio of dark energy to dark matter to regular matter based on our analysis of the statistics of this image. And you can see that there's a little bit more regular matter, a little bit more dark matter, a little bit less dark energy, and their estimate of the age of the universe increased by about 800,000 years based on this data. Another thing that they found is that there are some things that aren't explained by our regular vanilla theories. There are some small deviations from what we expect to find based on our vanilla theories of the universe. It seems to be that there's still a little bit of asymmetry to the universe that isn't explained away. And from the Copernican principle and all we know about how the Big Bang theory should work, the universe should be the same in all directions. But it looks like there may be a variation in, between the north and the south half. It's a little bit warmer on one half of the image. And some of the structures here are larger than what could have been predicted based on our understanding. So there's potentially new physics that's going to come out of this. And now it's over to the theorists to try to see if they can massage theories to better fit this data and see if we can understand a little bit more about how the universe has evolved up till now. So that's the end. Thank you.
Al? Quick question can I have the pointer for a second?
Sure.
Now, this is probably a mapping artifact, but the human brain is really good at connecting patterns and stuff, and I'm just wondering, I've seen maps from the different satellites, but I've never noticed this as an artifact. And I'm just wondering, do you have any idea? Can you see the line there? It's almost like an equatorial line on that sphere there. Do you think that's a mapping artifact?
That's our galaxy.
That line is the plane of our galaxy?
Yeah.
Very cool.
They have to subtract out its effect. So there's going to be probably some residual there because you're looking at, ripples of 1 part to the 10 to the minus 5. So the galaxy actually is a huge, they're 1,000 times more intense than the signal that they're looking at here. So any errors in subtracting out the stars and the dust
Oh, cool. Excellent.
create that
Thank you.
effect. You're welcome.
So our galaxy is positioned somewhere in the center then, eh? From the way the picture was taken.
It actually goes right across in a swath.
And we would be positioned then in the center of that picture.
Yeah, well, it's an all-sky image. So yeah, you're
Al, there was a lot of
it
talk
envelops
about,
us.
There was a lot of talk about it in the southeast corner. There was an area that's supposed to be empty. Can you explain that a little bit? Did you hear about that?
The cold spot.
They have,
It's supposed to be an empty area. There's not much there.
there's a couple cold spots there. I mean, there's one right here in the middle, and there's one over here.
That's right.
One thing that what you can actually do is that, these are photons that are coming from the most distant part of the universe, and anything in the foreground will scatter them away. And if you don't correct for that, you basically end up with an anomalous cold spot. They've used these cold spots to detect previously unknown galaxy clusters. Just because they didn't know there was a galaxy cluster, they found a cold spot in the microwave. They said there must be a galaxy cluster there. Something scattering the light out. So this, verifies that this is actually coming from the farthest reaches of the universe because they found a foreground galaxy cluster where no one knew there was one just by looking at this background radiation.
Talking about the space station, that AMS,
Yes?
is it possible that if we get Mark II, a new version, eventually that it might help us rather than, I know this is probably state of the art right now, but let's say 5, 10 years from now, as things progress, we may be able to solve that faster with better equipment?
Perhaps. I mean, I'm not sure exactly what the upper energy range of this is. The thing is, we don't really know how massive dark energy particles are. I mean, if they fall within the range of this, as you know, this has only been operating for a few months now, you know, on to a year. It's going to refine the upper energy levels as it progresses over, you know, it can operate for another 10 years, refining those upper energy levels, and we may start to see a more precipitous drop-off. It could also, I mean, these positrons could also be coming from positrons, the authors have said, you know, or from neutron stars, pulsars. That's another potential source of it. Neutron star positrons wouldn't drop off precipitously at a particular energy because they're just being accelerated in random processes. So it would be kind of a very smooth drop-off rather than a sharp drop-off. So they're looking for that high-energy drop-off, but they don't know where it occurs. This experiment took about 15 years to build. I don't think the ISS is going to be up there long enough for a new version to go up. But perhaps, you know, another experiment, you know, if they believe that, you know, it's going to be 1,000 giga-electron volts, there's no reason to think that it's, you know, within the range of this experiment. It could be, you know, 5 times the energy range before we actually see anything. Okay,
Great,
thanks.
thanks, Al.
All right. Michael, come and talk to us about this, this interesting-looking beast that you've got up here. Your home-built ultralight 14.75. Couldn't get that extra quarter of an inch in there, eh?
It wouldn't fit. It
Wouldn't fit in the car.
No. Yeah, it's kind of fun to bring us from the cosmos down to the backyard and the workbench. So I just thought I'd take a few minutes to tell you about this gizmo that I've been building in my house and trying out in the backyard. Just to start, maybe if we go to the next slide. This is an excellent book by Albert High on building ultralight Dobsonian telescopes, and I've gone through quite a number of different telescopes over quite a few years playing around, and there is this phrase about aperture fever and aperture wins. So one of my objectives has been to figure out the neatest way to build a large telescope that I didn't need a ladder for and that I could easily carry in and out because I don't have space for an observatory. So the idea of being able to carry it in and out means you don't want it to weigh very much for aperture. Next slide, please. Just one slide that's got only words on it, and this is a quick summary of the procedure or the process or the steps that I went through to come up with this telescope. So, I started actually with a mirror. I found a really nice, this is a quartz 3/4 inch thick mirror figured by Norman Fulham, who's one of the best mirror makers in the continent. Build the mirror box around it, add a secondary structure, and add some alt bearings to figure out where the thing balances, build a rocker box, check for the center of gravity, and then sort of an iterative process of refining each and every component as you play around with it and go back and around. Next picture, please. So here's the picture of the mirror box, and during the break you come up and have a look. I had already started doing this before I found the book by Albert High, but he mentions what a neat found object drum shells are. So this cylindrical piece of plywood is a snare drum, or from a snare drum. And you get thin plywood, so you get quite a rigid structure that way. The other thing, which I'll explain in a minute, is I didn't bother with a separate mirror cell. I just mounted the struts there in the bottom of the mirror box and have the mirror setting directly on its mirror supports. This makes it light and much easier to build. Next slide, please. Now, there's this is to my mind the most fun and interesting part, and I'll be of the discussion perhaps, because I'll be interested in people's reaction. One of the crucial bits in building a Newtonian telescope is how you're going to support the mirror. And the conventional wisdom is the more supports, the better, because the mirror itself, if you only support it in 3 spots, it's going to sag around there. So 6 supports are better, 9 are better, so you get the big mirrors like Attila has, and you have 27 support points. There is a piece of software that you can freely download called PLOP, which is an acronym for Plate Optimizer, and it uses a fancy mechanical engineering technique called finite element analysis, and it will allow you to design different kinds of mirror cells. You say, okay, I want a mirror cell that has only 3 support points. What's the optimal position? And it also gives you a readout of how many nanometers of deformation there is from an ideal mirror, if that's what in fact you started with. So I put in PLOP and I ran it in the upper right with 3 support points, then with 6, 9, and 18. And I think the conventional wisdom is you need at least 9 support points, and 18 would be better for such a thin mirror. What you see in the RMS row there are the actual deformations as computed by PLOP in nanometers. And remember that green light is around 500 nanometers in wavelength. And there's 2 things that I would point out about those numbers. One is that a 9-point mirror cell actually looks worse than a 6-point mirror cell. I was surprised to find that, but I've double-checked it. It's in High's book. It's, there are some websites with fancier software that come to the same conclusion, although I'd be pleased to hear an intuitive explanation. And the other is that even with 6 points, which is quite low, the amount of deformation is small relative to what you're going to ever need to see, particularly in Ottawa with jet streams overhead and things like that. So I went with a 6-point mirror support. Next picture, please. And that makes it really easy because all 6 points is those 3 teeter-totters. So if you look on the picture on the lower left, you'll see there's the standard 3 collimation adjustment threaded things with handles on them. But looking down from the top, you see I've just taken 3 pieces of aluminum channel, using the PLOP calculations, put the little support discs, little rubber discs on there at the right distance, and used a piece of a kid's snow slide to hold them from rotating when I put the mirror on it. So that's a very simple, I'm kind of a minimalist if I can get away with it in terms of design, a very simple way to hold the mirror. The next thing you have to worry about, and next picture please, is edge supports. And again, there's as I look through websites and all that, there's a huge amount of discussion about the best way to do this. Normally you don't have to worry about it as much because the mirror is supported on a cell, and when you go to collimate it, the whole cell moves. So the standard thought is you put support points at 45 degrees from the bottom on each side. Better yet is supposedly a sling, and some people are getting really fancy with these wiffle things. Well, I said, chuck all that. Let's do it really simply. I'm just going to rest it on the edge of the mirror box. Well, at first that was a crappy idea because I had something that was, some little fiberglass rods, and when I tried to move the mirror up and down, it got stuck on these rods and looked like a potato chip. But I replaced those with some pieces of Teflon so the mirror could slide up and down quite easily, and so far the weather hasn't been great, so I haven't been able to do that much actual star testing. It seems to work just fine. So there's the bottom part of the telescope. Next step is the secondary cage. Next slide, please. Here, by the way, there's a number of books I had studied up earlier on. You can get away with a single strut if you know a little bit about what makes it stiff. And stiffness isn't so much the thickness of the tubing wall, it's what the diameter is. So you can have a thin wall tube, but if it's a big diameter, and this is 2-inch, I think, it'll be stiff enough. And so the trick was to let's hang everything off the top of this single strut, this single tube. I like curved vanes because I don't want to look at the diffraction spikes that you see in a normal thing, plus, so you could make it straight. And I didn't figure that making that curved vane thick would detract too much from the total surface area of a 14 3/4 inch mirror. I made it quite adjustable. but it's still a bit not as nice as a professional mirror telescope in terms of the collimation there, but it's still a work in progress. In the old days in electronics, one talked about breadboarding, so this is still in a way a prototyping or breadboarding type telescope. And I've replaced the helical focuser with a regular one, but it also has a little electric motor in it. And so, as you can see, it's hardware store stuff, the U-bolts to hold the focuser plate with just a piece of 3/8-inch plywood to the stock, the single strut. Next one, please. So the curved vane, well, I think this is just another view, same points on the side. Next thing was to say, how do we mount this so that we can move it around and point to different parts of the sky? So if we go to the altitude bearing, next things, there's a very nice machine shop near Gary Sussex place, and so I had a chance to go over there and ask them to just cut me these two, actually I made 4 of them, these semicircles out of 1/4-inch aluminum plate, and drilled a few holes in them and put it together on some sliding bearings off another old telescope of some sort. And then I set it in a mirror box. Let me see what I say. So, there's the option. This picture shows a sliding weight on the back of the telescope there. So one of the things I'm still playing around with is making sure I get the balance right. And there, as you'll see, there's in a picture coming up, there's a way of adjusting the resistance by 2 pieces of Teflon that clamp those aluminum plates. Let's keep going. The rocker box, next picture, please. Again, really tried to keep it simple. So it's basically some pieces of plywood. The altitude bearings, those 15-inch diameter aluminum semicircles, slide on, I guess they're called cam followers. They're basically little round bearing things. So that there's no friction on the vertical, and on the horizontal, it's also a ball bearing Lazy Susan, so there's no friction there. The idea here actually comes, I don't know, has anybody ever heard of Molten bicycles? If you ever see one, it's a bicycle that's got an extremely rigid triangulated frame, and the engineer who designed it, a British guy named Moulton in the 60s, he looked at all these bicycle frame manufacturers who were trying to get just the right amount of flex in the frame. He said, this is stupid. Let's make the frame as rigid as possible and put the flex where we want it, and he was one of the first people to put a suspension in a bicycle. So my thought, analogously, is let's make the friction as low as possible with the ball bearings, and then just add some Teflon resistance that's adjustable where we need it. So both on the bottom, you see a little knob in the bottom back of the rocker box, and the side one allows you to adjust tension as you want. And I've also put some adjustable legs in case you take this outside and the ground isn't level. Next picture shows a little better the 2 tensioners. So on the lower right, you see part of the clamp that goes on the altitude bearing, and in the bottom, just in from the Lazy Susan that you can see is a knob that adjusts the Teflon that rubs on the Formica on the bottom of the rocker box. And I think the next one has a little more detail. So you can see again, on the lower left there, that's the adjustment for the azimuth motion, and up there is the adjustment for the altitude motion. Next slide, please. Now, one of the things I learned, this is not the first single stock curved vane telescope that I've put together. One of the issues here is collimation. And there's a prior step. It took me a while to figure out why things were always getting screwed up. And that is, you really have to make sure that the secondary is aligned on the optical axis of the primary. You don't worry about that in your own telescope that's in a proper tube. But here you do need to worry about it. And at one point, I have another telescope made by Takahashi, so I had a reason to call the Takahashi technical guy at Texas Nautical, and I said, how the heck do you collimate the telescope? And he said, I just set it down on a table, I stand back, and I look at it with my eye. And I said, wow, that's really high tech. But the trick is, if you stand back 2 focal lengths, your eye blows up to be the diameter of the mirror, and you want to make sure that the secondary is centered in the mirror when you do that. And so that's the first step. And then after that, collimation is more or less straightforward. Actually, you want to start with the primary mirror plane with the mirror box, i.e. perpendicular to the stalk. Now one more. And then from then on, collimation is as usual. Next slide, please. I use a laser collimator, so you first adjust the secondary so the beam is centered in the secondary, and then you adjust it so that the beam bounces down and hits the middle of the primary, and then you adjust the 3 knobs on the back of the primary until the laser beam bounces back on itself. So that's the remarks there, and just I don't think I'll ever bring it in, but the next and last slide, please. I'm also working on a 20-inch f4 Dobsonian. So here's what it looks. It has 2 struts, and I've set it's kind of like a folded Dobsonian because I've set the secondary mirror at a 22.5 degree angle rather than 45 degrees. And this is the biggest scope I ever expect to build because I think it's the biggest one you can make where you can still stand on the ground and look through the eyepiece at zenith. I'm not sure which one of these I'm going to motorize. I'll probably put encoders on it, but those are more projects. So this is a work in progress, and you're welcome to have a look at it during the break. Thanks a lot.
Do you worry about dew forming on the exposed secondary at all?
I haven't yet. I suppose if it ever arose, it's not too hard to run a little wire out there and put a bit of heater on it.
Some heating on it? Okay.
Yeah. Any questions? Yeah?
Yeah, you got the advantage of a quartz mirror, so you don't need any fans, right?
Although I am worried about tube current. Even though the tube is really short, it's only about 12 inches above the mirror, there's only a 1/4 inch. It's only 1/4 inch bigger around, so there may be air that's pooling in the bottom corner of it. That's what I was noticing when I had it out the other night.
The main expensive item then would be your lens, right? That's the biggest expense for the whole thing?
The mirror, yes. Yeah, that was what started this whole thing. I found a good deal on this spectacular mirror and built everything around it.
Question?
Just
Oh,
one.
one, wait, go another one back.
How much does the mirror weigh?
That's a good question. I think I weighed it, but I can tell you the whole optical tube weighs 27 pounds. So the mirror is 13 or 14 pounds.
Great, thank you very much.
I'd like to have a peek through that myself. All right. So Mark's going to come up and talk to us a little bit about a special event coming up. Mark?
Good evening, ladies and gentlemen. My name is Mark Mortimer. I'm with the Canadian Space Society. Did anyone else notice on the way in that wonderful advertisement, Star Wars, Next Identity? Following that idea along a little bit, you probably realized Star Wars recently got bought out by Disney World. And it kind of brought an idea to my mind because rumor has it Disney World is making another Star Wars movie. And I had this vision, Obi-Wan Kenobi getting sprinkled by pixie dust and saying, "Take me away, Lucas." And space science would never be the same. It scared me. I didn't want to see that happen. But there is a solution. More events, more public outreach. One of them coming up is Yuri's Night next Friday, which we're hosting at the Canadian Aviation and Space Museum. Your event the week after, being the Astronomy Day, fantastic opportunities to do this outreach. On Friday, we've got a great slate of people coming. We've got an engineer from Telesat who's going to do some talk about orbital mechanics. We have the students from the Carleton Satellite Design Team who are going to be coming to show their satellite. We have a experimenter builder of robots who's bringing a rover that's hoping to work its way to Mars someday, or at least the technology from it. We have the Ottawa rocket group coming, and they're going to do some demonstrations. Your very own Sylvie has fortunately found some volunteers from the Astronomical Society here to come out and help. I'm here today to try to get anyone else answer anyone's questions about tonight. If anyone else wants to come and help, if anyone else is kind of sitting on that fence, not sure if they want to come, they can volunteer or just come out and support everyone else, or bring your own telescopes. We are trying, if the weather's well, to have a star party that night. We believe we've hooked someone who's going to bring a solar telescope for the daytime as well, with the sun filter, of course. Fantastic opportunity, opening up to anybody who wants to come. It's free. No reason not to come out there and try to keep that Star Wars mentality in the movie theater where it belongs and keep reality. There is one possible sidebar to that. We do have a company coming up from Toronto. They're called the Adventure Travel Company, and they are selling tickets to orbital space adventures. I tried to ask them for a door prize. Really tried. It's about $100,000 a ticket, so they weren't quite ready to give me one. But they are coming up to at least give you a feel for what's happening. I believe they are teaming with X-Corps, and they're aiming for 2014 to get their flights going.
Wow.
Reality might be closer than we think. Thank you very much. That's all I have to say. Any questions? No, if you want to come see me at the break anytime, or call or talk to Sylvie, don't hesitate. Thank you very much.
Thank you. All right, thanks for your time on that. We have a whole pile of observations. That's why I had to sort of rush things along. Sorry about that. So we'll jump right into it. First and foremost, as always, Mr. Commission, what have you got for us this month?
This is the owl cluster in Cassiopeia. As you know, this thing is, since it's at plus 58, so it's visible the year round, but this object is about 6.4 in magnitude, so you'll be able to see that with a good pair of binoculars. It's an interesting cluster. Now, I might make this remark. I have a picture of this in black and white, and it's even better than this. Unfortunately, sometimes you're going for color, but you look at that picture and there's maybe about 5 or 6 reddish or stars or so. Sometimes some things just don't show up even in color as well as you think they would. The best thing for color, if you want to take color pictures, in my opinion, is all kinds of nebulae, gas, dust, that kind of stuff. If you have a nice, clean, open cluster like that, it makes very little difference. Thank you.
Great, thanks, Paul. All right, Deborah, you've got some good stuff for us there. That's beautiful.
Sort of.
I love that. Go for it.
Yeah. Thanks, Paul. Good evening, everybody. Well, this was a comet that finally we had a naked eye comet. I'll go see. But it turned out to be like a itsy bitsy teeny weeny yellow polka dot bikini comet. And in order to photograph it, it would be kind of boring without some kind of a landscape or foreground. So Peter and I jumped in the car after work on Friday, March 15th, and went out past Carp, and we kind of went down Carp Road, Thomas Dolan Parkway area, and stopped, and it was really freaking cold that night. The wind was really howling. It was like minus 20. It was miserable. And there was this huge bank of cloud coming, and I thought, good, because I'm cold. I want to go home. So we took this photo, and lo and behold, the comet actually showed up in the photo. See it up there? Before it was overtaken. And then the next night, we'd invited Doug George to come out with us. We were going to meet up at the Diefenbunker in Carp, And we looked around and we thought, well, this is pretty boring here. There's no foreground. So we went back to the same place on Thomas Dolan. And there's, Peter took this photo across the street, and I'll mention about the camera he used in a minute. There's the farm. It's actually pretty far away, that farm, but it looks really close. And that was the next night. That was Saturday night. And it was another really cold night. And my fingers were freezing and I couldn't see what I was doing. And the next slide. Now this is the photo that was ended up in the Citizen. Now you give a photo to the Citizen, they take liberties with it because it was really lightened and it looked like it was daytime. And that, did you notice that? I mean, geez, you know, it was really light. Looked like a daytime comet. But I couldn't see this farm. It was pretty far and it was pretty dark and I didn't even notice there were horses there. I thought that was kind of cool when I developed it, or not developed it, I Photoshop developed it. And there's the comet, and that was getting closer to the horizon. It was a nice clear night finally. So it was nice to see. And the last one is this. Peter took this. He was across the street with this little tiny pocket camera, Canon G15, like I keep it in my purse just as a backup camera. And he actually got the comet. I mean, yeah, it's not a great photo and everything, but it was a little higher in the sky and a little bit of sunset happening. But he pushed it to 12,800 ISO. And it was handheld. It was not on a tripod, it was actually handheld. And he actually managed to get a shot of the comet with a little tiny pocket camera. So I thought I'd throw that in there. It's kind of cool. So that's it. Thanks.
Great. Thanks, Deborah. Okay, Rob, we're going to ask you to come on back.
Now, this comet could not be seen with the naked eye. So, and that's about what it looked like. And if you look very carefully, I don't know, I couldn't see it when I glanced at the back, but you can just barely make a spot, because I use this here, right there. Photoshop, sorry, PowerPoint doesn't allow you to point the arrow exactly where you want it. So this is where it was, very, very cold. It's a frozen lake. And this is a wide angle shot, and I was guessing approximately where it was just from where the sun set. But I took a series of pictures through a 135 millimeter telephoto lens, and again, I couldn't see the comet at this time, even through the viewfinder. So these are several second exposures to try to bring it in. But what it does is it shows it getting closer and closer to the horizon. Here we go. Goodbye. And it was cold. That's the last I ever saw of it. Until maybe this weekend, I don't know. It's getting better? Is it getting any brighter?
It's not bad, it's higher.
It's higher. Oh, okay. Okay, that's all I got.
Thanks, Rob. Gary?
Yes, sir. I'm back. This is the view outside our bedroom window when we open the drapes. Just looking at the moon in the morning when it's up and just get a beautiful eastern sky. So this was really the first clear morning we had since we moved in, and picturesque. I just couldn't believe how beautiful it looked. Nice little crescent moon. Next slide. Then the comet. Well, I was out the same night as you, Dad, that very, very cold night. We were on old Almont Road with a couple of friends. In fact, Joe Bonner had his Canon on a tripod. He kind of like went around the car to get warm, and the wind actually blew the tripod over. It was that windy. So 2 nights later, I'm just in my office at home looking through the window, and I see it with binoculars. Not freezing, staying nice and warm. So I was able to get this on my property. I was very, very, very excited to get this comet because I haven't had a very good past history with photographing comets. And next slide, please. Moonrise through trees. I've always wanted to get one of these. See, where I lived in Barrhaven, I never had an east horizon. Our house was in the way, and I only looked for the western stuff, so now I get almost a 360 degree. Just how we had a little thin cloud here, so I didn't get a very crisp image of the moon, but it got a little higher later, but then I wanted to get the silhouette of the trees. Thanks. And that's it. And you saw the previous comment of the slide of the comet. Thanks.
Great. I've got a few for you as well. I'll rush through these. we had our first visibility on or around March the 13th, and I did manage to get out, and I couldn't see it either. I agree with you, Rob, at least on that date. And I only had moments to photograph this from my location before that cloud. This one's for you, Brian. Actually, you can see this is the cloud monster about to eat the comet. You're always seeing faces, right? So, and it did. 30 seconds after that, that comet was toast for the night. But as Deborah mentioned, on the night of there it is there in case you can't see it. On the night of the 14th, the following night, that was a nice night. It was nice and clear. I went out to Dalhousie Lake and managed to see it, although I almost missed it. I didn't find it. We did have a low bank of clouds just above the frame here, and so I only saw it just shortly before it set. 30 seconds after I took this shot, it was down below the tree line there, but did manage to get a nice image of it before it did so. So a nice frozen lake in the foreground with somebody's cottage there. The following night, I think I've seen it about half a dozen times. Following night was the 16th, and I think that was the clearest night certainly that I've had with it. I managed to get some nice stuff there. I threw this picture in of the moon itself because I wanted to give you a sense of scale for how big this thing really is. So that moon was shot on the same evening as the comet, and I managed to get that of the comet. Wow. And you can see this is a stack of 4 1-minute shots, and you can see the thin ion tail up there. And you can also pick up some structure in the dust tail there. And again, this was only a few minutes before it actually set, before it dived down below the tree line there. But yeah, certainly one of the best nights for it. Very clear, very good seeing that night.
What's the name of that comet? Is it fan stars?
That's pan stars. Yeah, these are all pan stars.
Fan with an F. Look at the beautiful.
The fan stars. Yeah, that's right. Yeah, that fan tail is even wider now. So yeah, that was a good night there. On the following night, I went out, and since I'd worked with the DSLR on the previous night, I thought I'd try to do something with the Malin cam because, as Deborah pointed out, it was freaking cold those nights. The wind was just biting there, so I just set up the Malin cam on a tripod to see what I could get. And again, I just threw this in for scale. That's M42. And then I managed to get the comet. So these are all at the same scale. And again, this is just with the Malin cam with the what did I put on this? This is through a 70 millimeter Apo. So you're missing. It's just really the bright part of the comet. And what I did with this also is after I managed to get a few shots worth stacking, I ran that sequence there. Chris, if you can give that a click there. There you go. It should clarify in a minute there. And again, that was a very clear night. It was windy there, and I just basically followed the comet down to the ground. You can see it just about to dive into the trees there. And away she goes. Interesting things you can do when you should be inside being warm. So that was the 17th. Then we had a spate of cloudy nights, and there was not a lot of comet action until last Friday. This is a shot from last Friday. Again, still freaking cold, still very windy, not at all like spring. But the Malin cam, at this point in time, now the comet was at least getting higher in the sky, and it was visible after the end of astronomical twilight. So getting into dark skies there again, and you can see how the fantail has actually increased in its width there. So this was a really nice opportunity. I was freezing my butt off, and I was going to pack it in. But as I was getting ready to pack it in, something kind of magic happened, and I'm really glad. In the last minute, I took my DSLR with me. I hadn't intended to use it, but in the last minute, I managed to get that, which was really cool. This auroral display lasted all of about 15 minutes, and I'd already packed away the Malin cam and the rest of it. And I saw this auroral ray forming in the northeast, and I thought, oh my God, that's an aurora. I haven't seen one for a while. It faded very quickly, and then these 3 spikes formed almost simultaneously, but they were moving really rapidly across the sky. And so I was looking at them, and I thought, if I time this right, I can get the comet just between a couple of the spikes there. And that was a lucky shot. It was a single shot there. Yeah, there we go. Thank you. Also here you can see embedded in one of the rays there is the Andromeda Galaxy. And literally within about 5 or 6 minutes after I took this shot, those rays were gone, and that was it for the auroral display that night. So that's what I've got. I think that was my last one. Yep. Yes, it is. Okay, thanks. This is Tim. You're going to talk about this one.
Yeah.
This is an interesting one.
Yeah, this one's kind of fun. On the 30th, the museum had their second Earth Hour. Don't ask. Anyway, we had a visitor who came by who was wondering, how did you take pictures to the 15-inch? I suggested that some people have had nice pictures aiming their cell phone cameras into the eyepiece. So this is this young lady's first astrophoto, aiming a simple cell phone camera into a 21mm eyepiece in the 15-inch. And this is the kind of thing you can do when you have a very cold, very bored astronomy educator coaxing you to do something. And you give it a shot. And there you have it. And that's it.
Great. Good outreach there, Tim. Excellent. What can I tell you? There we go. All right, next up, Gordon.
Apparently can't do this without my assistant, so here's my comet shot. This was March 17th. It's about 10 after 8, just down near the Ottawa River in Orleans. An observation was made with 1050 and 1570 binoculars, and the sketch is done in colored pencil. Next, please. Double colored star for you. In Coma, it's 24 Coma Berenices. It's also a Struve 1657. They're an optical pair, very near M85. Next, just for fun, they're always nice, M81 and M82. And next, I can't guarantee that I saw this. The note in my log cites this as being a persistent smudge. It's in the location where IC 2574 Coddington's Nebula is supposed to be. If I moved the telescope, it moved with everything. I couldn't see it in my 12-inch a few nights later. This is done with the 120 refractor. And one last observation that I don't have any sketches for. Paul, about 2 years ago, you gave a challenge object in Gemini. I think it was 2158.
That's right. That's the small one besides M35.
Found it. Was looking at all of the stars that I would have to put in to sketch this sucker. And while I was thinking about it, it thankfully clouded over. So, but I found it. Thank you.
That's good. Better late than never, right? All right, Bob, all yours.
This is my comet shot, and this is just with a Canon Rebel DSLR. And the story behind this is this shot was taken at about 8:30 at night, and my wife and I and a couple of our neighbors went out to see this at 8 o'clock. This picture was taken at 8:30, and about 29 after 8, they mumbled and they're freezing to death and something about friggin' idiot, and stomped off, all three of them. I was left there by myself, couldn't find it, searching around madly, and then, they were barely out of sight, doors slamming, and there it was. I found it, so I rushed back and got them, and so they had a chance to see it. Next slide, please. And this is just I just cranked up the zoom on my camera and took this picture of it. And do you notice how the comet is exactly the same color? This comet here is right here. No, those are the same shade, and this is the twilight disappearing down into the sky. So, seconds earlier, the comet was in this color, and we just can't see it. And so it's, anyway, that's it.
Thank you. You think?
Yeah, I think so. Next.
Okay. Rick.
So there is something in the sky besides just the comet, Friend of mine has gone off to school in Saskatchewan, and while he's gone, he has no use for his hydrogen alpha filter, so I've borrowed it and been just starting at trying to image the sun in hydrogen alpha. This is just a black and white version. Normally they come out, the hydrogen alpha light is a very dark red, and the pictures all come out very dark red, and so almost everybody changes the color to give them a nice sort of solar yellow. I found this one seemed to retain a lot more detail in just black and white. Next. And keep with the sketching theme, this is was really poor seeing. This was back in February, I think, with an 8-inch telescope and white light solar filter. This was a particularly interesting sunspot group. The seeing started off not too bad, so I decided it was worth trying a sketch, and the seeing rapidly deteriorated. One thing I did on this sketch, normally when you can see the little white patches down at the bottom. These are faculae, which are little bright areas that surround some of the groups. And so normally what you do when you do a drawing is you put little dashed lines around those, because of course you're using white paper. How do you put something even whiter on it? But what I did was then when I scanned it into Photoshop, I just put a uniform slight gray haze and then erased the gray where the faculae were. So normally you'd be able to get a lot more detail with a 4-inch, 6-inch, 8-inch telescope and a white light solar filter. Under good seeing, you'd see a lot more detail than this. So this is just sort of my beginning attempts at sketching. I've bought some equipment now, so I'm hoping to do some lunar and deep sky stuff as well. Next. Just a quick shot of the Alpha Persei cluster. So that's the center of Perseus. And it's one of the closer and larger clusters. This is, I think, with a 50 millimeter lens, probably 5 or 6 minutes exposure, with the camera mounted on a barn door tracker. And next. The zodiacal light we were talking about last month. So the zodiacal light, the planets all orbit the sun in a plane. Well, there's not just planets and asteroids in there. There's also a lot of dust and dirt. And the sun reflects off of that. And so what you're seeing there is the dirt in the plane of the planets reflecting the sunlight. The sun's just below the horizon. This is just after twilight. And this was taken from the ice out in front of my house. With a 10 millimeter lens, so that's Jupiter and the Pleiades up at the top, Perseus and so forth. Next. And I did actually shoot the comet as well. This is the only shot I brought tonight. It's kind of messy because, of course, the first few images, these are each 2-minute exposures, 100 millimeter f4 at ISO 1600, again mounted on a barn door tracker, and I just set it to take 2-minute exposures for, I guess, 10 of them. And it started out in twilight with a nice blue sky, and then as the set down into the munge of the atmosphere and stuff, it got browner and browner, so it took a lot of tiddling to try and get rid of that. You can see I'm in the flight path, so there's an awful lot of airplanes going by, and it was just starting to disappear into behind a tree on the right side, just as I stopped the exposures. But again, we've got, let's see, pointer here. You can see the galaxy there with the dark lane down the side, M110, M32, and then the comet down at the bottom. And I think that's all. All right, thank you.
Nice catch, Rick. Okay, Rolf, you've got one for us as well.
Okay, so this was an attempt to get it through a telescope. This is through a 6-inch telescope and a DSLR. And you can see the stars have streaked a little bit because this was a series of 10-second exposures stacked with the comet centered on the stacking, so that you can see that in the space of about 5 minutes, that's how much the comet moved relative to the stars. And also, to get better detail on the head, I also took a series of 1-second exposures to get the nucleus within the head, rather than have it all overexposed. So this is, attempting to get kind of the dynamic range of brightness that you might see visually. The color, I guess, is also kind of striking because it wasn't, the color was quite obvious for this comet. It was kind of a beige color, which you could see in binoculars quite clearly. So visually, I think that the color was somewhat like this. Very difficult, though, because it was never in a dark sky, so you could never really get a good rendition of the color. And I tried to make this sky kind of neutral, but seeing it on the screen here at first, it seemed a little greenish. I don't know if that's a good rendition here or not. But anyway, that's it through a 6-inch telescope.
Great. Thank you, Rolf. And John. John, you here? There you are.
This image was just taken early Thursday morning around 5:15. Where I live southeast of the city, most of the light pollution is in the northwest, where the comet is in the evening, so it was easier. I have a darker sky in the east. I took a series of images with a Canon DSLR Rebel, hoping to stack them, but I didn't have time to stack them. But this was a single 6-second exposure, and it happened to get a meteor as well as M31 and the comet. And at that time, neither the comet nor the galaxy were visible from the naked eye, but the lens was able to pick that up. And that was just taken from my my back deck at Carlsbad Springs, southeast of the city.
Great. Thanks, John. All right, Bob has graciously offered to delay his talk until next month. Thanks again, Bob. We went a little bit over with the unexpectedly large number of observations that we had. So, Bob, you're definitely on deck for next month, and I do look forward to hearing that. So, as was mentioned before, the comet is still available for viewing. It is receding. It's getting dimmer. On the nights of around the 16th to the 17th to the 18th, even as late as the 23rd or so, I certainly found it visible to the naked eye. Not so much in the last little while, but certainly a treat through even binoculars. So if you haven't had a chance, tomorrow night's supposed to be half decent. Go check it out because the moon is not in the sky. The comet is reasonably high after the end of astronomical twilight, so get it while you can. All right, just in summary and wrapping things up, Estelle is here, and she has her pick of the month is Strange New Worlds. It's the search for alien planets and life beyond our solar system, so probably a rather interesting read. All right, and again, just a reminder that International Astronomy Day here at the museum on Saturday, April the 20th, so 2 weeks from tomorrow. And lots of activities. Hopefully the weather will cooperate. We'll have some great solar observing. We'll have some indoor exhibits, and we'll have a talk going on in the auditorium as well. And there's no additional charge for admission to any of those events, just the charge for getting into the museum. So if you're interested you're still looking for volunteers? So Chris is nodding yes. So if you've got some time and you'd like to pitch in and help out, contact or come up and see Chris after the meeting there, and he'll get you on the road there. And we always appreciate volunteers. All right, our usual post-meeting entertainment. As I say, we have Estelle. Al is available to talk to about equipment if we still have some available. Art and Ann are here tonight. You can have some coffee and goodies. Talk to Art about membership information and cards. And Stephen, I take it, is not here as usual. No.
Rest of the museum is closed, and we have our usual standing reservation over at Kelsey's if you feel like you need to wet your whistle and get into some more Astro Geek talk, so you're more than welcome to join us. All right, 135 tonight, good turnout. Thanks for everybody for coming. Thanks to all the contributors for their work, and wonderful selection of images. Thanks for the time that you spent on processing those and sharing those with the members. And again, thanks to the museum for hosting us. Complaints, comments, and suggestions, there I be. All right, so next meeting, May the 3rd, usual 8 o'clock, and hope to see you all there. Good luck with your comet observing. No excuses for not seeing it, because it is getting milder. It's supposed to be milder. It won't be quite as freezing on the fingers. So good luck with that. Clear skies. Have a safe drive home, and we'll see you guys all next month, hopefully. Take care.